let's talk about what they are talking about here.
Okay.
Best way to do that is to go down and look at number 2.
Yeah.
Okay? There are 4 lines there that form a rectangle.
Yeah.
It's not a horizontal or a vertical rectangle. It's kind of a slanted rectangle.
Mm-hmm.
How would you know that's a rectangle? What would have to be true?
All the angles would have to be 90 degrees.
Which means this line would have to be perpendicular to that line.
Yeah.
What is true about, can you see my hand here?
Yeah, I can.
What is true about that line and this line down here?
They're parallel.
Parallel lines have the same what?
Length?
Slope.
Or...
They do have the same length, but we're not going to need that here. Parallel lines have the same slope. Okay? What about this short side and this short side? What is true about those two if that's a rectangle?
They're parallel and have the same slope.
Now, for this to be a rectangle as opposed to just a parallelogram, we've proved that it's a parallelogram if I can prove these two have the same slope and those two have the same slope. Well,
Yeah.
to prove that it's a rectangle, we have to prove that that line is perpendicular to that line.
Mm-hmm.
What would be true to make that perpendicular to that about their slopes? What is true about two lines that are perpendicular to one another? What's true about their slopes? One slope is what of the other? The negative reciprocal.
Okay.
Okay? By that, I mean the following. If I have a slope that's equal to 2, well, the slope of the perpendicular would be what?
-2.
Negative 1/2. You always have to do two things. You have to reciprocate it, and you have to change its sign.
Yeah.
Notice I did two things here. If you're only doing one thing, you're never doing it right.
Yeah.
Unless the slope is 1. And then the reciprocal of 1 is 1, so all you have to do is change the sign on that. But this is the key. For that to be a right angle, the slope of one line has to be the negative reciprocal of the other. So the key to problem 1, hold on a minute. You know, see, now I can't blow it up. Interesting. Well, the key to problem 1 is to figure out the slopes of each of these 10 equations.
Yeah.
Is that what you've done? That's what these numbers are here? No, they're not. So,
no, I didn't solve them.
well, what's the slope? Here, I need my other page here. Okay, good. Now I can do it. So let's number these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Okay.
What's the slope of 1? Put it into y equal mx plus b format, and what is m?
2.
Negative 2.
-2.
In other words, I got to move that on the other side of the equation, right? So it's going to be y equals negative 2x plus 8. Well, that's the slope, negative 2. So we're going to take every one of these equations and figure out their slopes. That's all we need to do to figure out which 4 are going to make a rectangle. How about number 2? What's the slope on number 2?
would it be -2 again?
No? Let's solve it.
Okay.
I don't really care about that 1, but in other words, we want to solve this for y, always. When you want to solve for slope, if it hasn't been solved for y, some of these are already solved for y. So we don't need to manipulate any, we can figure out what the slopes are. But this one we got to solve for y. In order to solve for y, I got to move everything else to the other side, changing the sign. Now I got to divide everything by 2. That gives me a slope of -1/4. Like I said, this number over here is immaterial. Only thing we care about here is the slopes. So this slope is -1/4. Now, let's do that for all 10 of these, and we'll find out which slopes are parallel and which slopes are perpendicular. And we'll know the 4 lines or the 4 equations that make up the rectangle.
Okay.
What's M3? Move the x to the other side and divide everything by 2.
So
we got 2y plus x equal 1. Well, I got to get this x on the other side. And I want to put it in front because that's the beginning of mx plus b format, which means y is equal to -1/2 x plus 1/2. Slope's -1/2. That's all you have to do on all of these. Is first of all you have to solve it for y, and then take the coefficient of x on the other side, that's your slope. With me?
Okay. Yeah.
Okay, so what's the slope of the 4th box? That's already pretty easy. That's in mx plus b format already. So what's the coefficient of x?
1.
That's the slope. Just because it's not written doesn't mean it's not there. Okay.
Okay.
What's the slope on the 5th one? You do have to distribute that, but after you distribute it, what's the coefficient of x?
Negative.
Distribute this. What do you get?
Y.
You know what I mean by distribute it?
Yeah. Okay. Y equals 2x minus -2.
-2. Minus the -2. -2. But once again, I don't care what this number is over here. It has nothing to do with my solution. Only thing I care about is slope. What's the slope here?
Y equals -1/2.
What is m?
-1/2.
No, it's 2. Here's the form. Y equal mx plus b. M, whatever the coefficient of x is, that's the slope. Well, the coefficient of x here is 2. Right? Not this 2 over here. I don't care about that 2. That's not going to have anything to do with my solution. What I care about is the slope, and the slope is the coefficient of the x term.
Okay.
Okay, so it's 2. Now, m6. It's the coefficient of that. Once I solve for y, what's the coefficient of the x term?
Uh,
There's the equation. How do you solve for y?
divide by 2.
Okay, so y equals x over 2 minus 4 over 2. What's the coefficient of x?
1.
1/2. X over 2 is exactly the same as 1/2 x, notice. So when you see x over 2, that's 1/2 x, 1/2 is the coefficient. So the slope on the sixth one is 1/2. Okay?
Okay.
Sounds like algebra might be what we need to look at here. What's the coefficient on number 7? Remember, you have to get it into y equal mx plus b. In other words, you have to solve for y. I don't have to solve for y on number 8. It's already solved for. Same on number 9, but on number 10 it isn't. I got to do stuff to it. Well, what do I have to do to number 7 to solve for y? What do I do with that plus 2x?
Subtract it.
Right. Which gives you what on the right side?
Negative 2x.
So what's the slope of this equation?
Negative 2x.
Negative 2. Just the coefficient. It doesn't include the x. In other words, look at this. Y equal mx plus b. M is the slope. No x. Okay?
Okay.
What's the slope on 8? Don't have to do anything to that. It's already in y equal mx plus b format.
So it's 1/2.
Okay? What's the slope on 9?
Negative 1.
Good. And what's the slope on 10? We got to manipulate it a little bit.
1/2.
Negative 1/2. In other
Negative
words, when I divide both sides by 2, I end up with 4 over 2 minus x over 2. Coefficient is minus 1/2.
Okay.
So those are the slopes of our 10 lines. Now, we're looking for 2 lines that have the same slope and 2 other lines that have the negative reciprocal slope. Well, I see a couple possibilities. M1 and M7 both have a slope of minus 2. And the negative reciprocal of that would be positive 1/2. So if I take this one, those are my 2 parallel sides of the rectangle. And then this one and this one, they're parallel to each other and they're perpendicular to M1 and M7. So those 4 equations would represent a rectangle.
Okay.
And I could find 2 other sides that have the same slope. Notice that M3 has the same slope as M10. So those 2 lines are parallel, but there are not 2 answers where the slope is 2. And that's what I would need for there to be 2 more lines that were perpendicular to these. So I not only have to find 2 pairs of equations that have the same slope, but I got to find two other equations that have the negative reciprocal slope.
Yeah.
I believe the four that I've circled are the only combinations that work. This one, there's no other 1/4. This one, there's another negative 1/2, but there's only one positive 2, and I would need two positive 2s. So
Yeah.
there's only one positive 2. There's only one 1, so that can't be an answer. There's only one negative 1, that can't be an answer. And I've ruled out this because there's only one positive 2. So the only four left are the four that I've circled. And they do indeed make a rectangle.
Yeah.
So let's talk about your explanation here, what it should say.
Okay.
We've got our answer, but the explanation really should say you want two of the equations to have the same slope and two of the equations to have the negative reciprocal slope, the perpendicular slope. And that's all. That's all you need to say. Notice that I never had to deal with that 8, that 1, that 1. The only thing I have to do is put it in y = mx plus b format and solve and figure out what m is. That's all I have to do. Once I have the slope of all 10 of these equations, then I can answer their question. And that's what we did.
Yeah.
But you've given an answer here that indicates that you're saying the distance has to be the same.
Mm-hmm.
And that's a little problematic because it's going to be tough for us to figure out the distances. In other words, it is true that this side is equal to that side if it's a rectangle, and this short side is equal in length to this side. But we don't need to figure out distances to prove it's a rectangle. It's a rectangle if that's parallel to that, that's parallel to that, and that line is perpendicular to that line. That's all we need.
Okay.
That proves it's a rectangle. And so your solution here, don't talk about distances, talk about slopes only. You need two equations with the same slope and two equations with negative reciprocal of that slope. And we found it. M1 and M7 have the same slope, and M6 and M8 have the negative reciprocal of that slope.
Okay.
Okay? Now complete the drawing below to show the four lines and the x and y and label them clearly. Well, to graph these, we need to graph these four equations. Okay? So let me just do that. Let me get rid of all the ones that don't count, don't matter. So it's these four equations that I got to graph.
Yeah.
First equation. And to graph it, put it into mx plus b format. That's the first equation, is it not?
Yeah.
After I've altered it.
Yeah.
In other words, I can't graph it when it's like that. I don't know how. But once I get it in mx plus b format, I know how to graph it. Where do I start?
Yeah. At 8 on the...
There's 1 point on my first line. Now what? I need a second point. To draw a line, I got to have 2 points.
Then you go down 2 and left 1.
If I did that, I'd go down 2 and left 1. What kind of slope would that be? Positive or negative?
Negative.
No, that's a positive slope. If I do exactly what you told me to do, I end up with a positive slope. So you're close. I got to go down 2, but I can't go left 1. I got to go right 1. So I go down 2 and go right 1. Now that's a negative slope. And that's the equation of equation 1. Okay? Now,
Okay.
let's find the line that's parallel. That's equation 7. And let's graph that. Well, let's rewrite equation 7. That's this one over here. So tell me, after I manipulate it and put it into y equal mx plus b format, what do you have?
Y equals negative 2x minus 2.
Okay, let's plot that. Where do I start?
Negative 2.
Okay, which is right there. And how do I handle the next point?
You go down 2 and right 1 again.
Gives me a second point there. Connect those 2 points and you should have a parallel line with the first equation. Okay, that's relatively close. Now let's examine the other two, M6 and M8. In other words, I've graphed that one and that one. Now, M6, 2y equals x minus 4. How does that read after I put it in mx plus b format?
Y equals negative 1/2.
Where are you getting the negative? Oh, well, hold on. How do I solve for y?
You divide by 2.
So you get y equal, and I can write this either x over 2 or 1/2 x. They're both the same thing. Very important to understand that. Now, where do I begin graphing that?
At negative 2.
Okay, that was this point right here.
Yeah.
And how do I get a slope of 1/2? Positive.
You go up 1 and left 2.
I went left, that give me a negative slope again.
So up 1 and right 1.
Correct. So I go
Or
up
right.
1 and right 2.
Yeah.
And that line becomes perpendicular to the other two, which we knew it was, right?
Yeah.
And that's a positive slope. Are you clear on what are positive slopes and what are negative slopes? I went through that drill with you once, didn't I?
Yeah, I know what they are.
Okay, cool. And it doesn't matter as long as you do rise over run. There's lots of ways to handle that second point. I could go up 1 and over to the right 2. Up 1 and over to the right is the same as down 1 and to the left. Still getting me that line. Okay? So, finally, the last one we got to do is M8, which we don't have to manipulate to put it into mx plus b format. How do I graph that?
You start at positive 2.
Okay, that was 8, so 2 is going to be right about there. And how do I graph its slope? In other words, I got to get a second point. I can't draw a line until I have 2 points.
So you go up 1 and right 2.
Correct. Up 1 gets me to about there. To the right 2 gets me to about right there. Connect those 2 points. There's my rectangle. Okay? Now, notice what the directions say on number 2. It says, complete the drawing below to show the 4 lines and the x and y axis. They didn't put the x and y axis on their drawing. So, in fact, no, our drawing looks close enough to their drawing. The x and y axis, can you see where I'm pointing here?
Yeah.
I don't know that that's the y axis. It's tough to tell. But anyway, you need to duplicate that somehow in this drawing of theirs.
Okay.
Okay, I'm very close. In other words, I graphed it from scratch, which is probably the easiest way to do it, as opposed to trying to use this grid that they didn't put on. They put a grid on there, but they didn't label the x-axis or the y-axis. So I would do it my way, and then you have to figure out where to put the x-axis and the y-axis, which can be a little tricky, I guess. It looks like that's probably the y-axis, and the x-axis is probably that line. In other words, the middle of all of those dotted lines, I believe, is the x-axis, and this line right there is the y-axis. At least that's what it looks like from my drawing, which, granted, was approximated. In other words, I didn't have a grid over here. I just approximated that that was 8, and this was minus 2, I believe.
Yeah.
Okay. In other words, it's harder to do what they want you to do here than it is to graph it from scratch. Graphing it from scratch is pretty easy. Because all you're doing is graphing 4 lines that are all in y equal mx plus b format.
Yeah.
All right. Let's see. That was the only 2 you had, and we're out of time anyway. So
yeah.
I hope that straightens it out. This is
that helps.
Question. I like the fact that they gave you 10 equations here, and there's only 4 of them that fit our criterion, which is 2 of them have to have the same slope, and 2 of them have to have negative reciprocal slopes. Always remember that when you're finding the slope of the perpendicular, you have to do 2 things, not 1. Everybody makes the mistake and only does 1. They either take the reciprocal or they take the negative, but they don't do both. You got to do both. If one slope is plus 2, then the perpendicular has to be minus 1/2. And we found 4 lines like that, where we had 2 lines that had the same slope and 2 other lines that had negative reciprocal slopes. That's why we were able to identify which 4 lines. And those were the only 4 equations that fit our requirements, which is to have 2 slopes that were the same and 2 slopes that were the negative reciprocal of the first one. I'm not sure when you write this explanation here that you need to write these equations. I would not. I would just say you're looking for 2 lines that have the same slope and 2 others that have the negative reciprocal of the first 2. That's all you need to do. That defines a rectangle. You don't care about anything else other than slopes, not distances. It is true that this distance has to be the same between those 2 points, but that's going to be hard to figure out. We don't know those 2 points.
Yeah.
But a rectangle merely needs parallel opposite sides and perpendicular at every angle. Has to be perpendicular. So it's really easy to solve using slopes only. Now, to graph it, notice I actually had to use the b, the y-intercept, in every case in order to graph it.
Yeah.
So this b is not completely unimportant. It's important in terms of graphing it. It's not important at all in determining which 4 equations we're looking at. To determine which 4 equations we're looking at, we care about slope and only slope.
Okay.
The key to finding slope is to always put it into y equal mx plus b format, which means a lot of algebraic manipulation.
Okay.
Okay? You just want to end up with y on one side of the equation all by itself and everything else on the other side. And then take the coefficient of whatever the x term is. And that's your slope.
Okay.
All right, Connor. Well,
thank you.
You're welcome. And I will talk to you next time.
Talk to you next time.